Okay, question number 2. Remember, this is actually question 37 on the 2018 June Regents exam. So this is the big 6-pointer. That's why I'm making a video, so we can go through each thing step by step, and you can revisit it if you need. Dylan has a bank that sorts coins as they are dropped into it. A panel on the front displays the total number of coins inside, as well as the total value of these coins. The panel shows 90 coins with a value of $17.55 inside the bank. So Dylan only collects dimes and quarters. Write a system of equations in 2 variables, or an equation in 1 variable that could be used to model this situation. They give you the choice. I like to write systems in 2 equations. I just think it's a little more straightforward and it's easier. So the first thing I want to talk about is coins. There are 90 coins total in his bank. So let's define our variables. Always define your variables so when you get to the end of a problem like this, you know what you solve for. It's just so much easier. So for the coins, I'm going to say D equals dimes and Q equals quarters. So this first equation, when I'm talking about 90 coins, I don't know about which coins are which, but I know that D plus Q equals 90 because there are 90 coins. So that's our first equation. Now the second equation deals with how much actual value the money has. So be careful with your decimals. A dime is not 10, it's 0.10 because it's only worth 10 cents. So 0.10D plus 0.25Q equals a total of $17.55. So that's our system of equations. So right here, this is probably good, and we'll check the rubric at the end, but I think we've got 2 points so far. Okay, so like I said, I'm going to even go through the rubric after this problem to show what each part of the problem happens to be worth. Okay, so I want to solve this system algebraically. And this is one of the wrinkles where if you don't do the algebraic part, there is no way to get the full 6 points. So when I look at these 2 equations, the bottom one is kind of ugly, so I really don't want to mess with that. So I want to get rid of one of these values, either the dimes or the quarters, because you can really only solve for one variable at a time. So doesn't matter which one I choose. For me, I see this 0.10 in front of D, so I want to make the D go away. So I'm going to distribute 0.10 for everything in my first equation. So to make it go away, I need a negative 0.10 times D minus 0.10 times Q equals 90 times negative 0.10. So when I go through and clean that up, it's just negative 0.10 d minus 0.10 q equals negative 9. And now this other equation, I'm just going to bring it across just like it is. So 0.10d plus 0.25q equals 17.55. And what I've actually done is set this system of equations up where I can add it together. And the reason that I chose that negative 0.10 for my d is because now the two values of d are exactly the same, except one's positive and one's negative, so they cancel each other out. So doing that, now when I add these two equations together, 25 minus 0.10 or negative 0.10 plus 0.25 gives me 0.15 q equals 17 minus 9 is 8.55. So we're using the addition method to solve this. And once I'm down to one variable, we can always solve an equation for one variable. Here, we just want to get q alone. So I'll steal this and divide both sides by 0.15. And my result, q, and even though we did this algebraically, obviously when you get to 8.55 divided by 0.15, that's calculator work. And we get q is actually 57. Now, we've got two equations to choose from to find d. I like the first one because it's a lot more straightforward. So I'm going to substitute in my q. So d plus q, which is 57, equals 90. So there, all we have to do is subtract 57 from both sides. So 90 minus 57 leaves 33. So the solution to our system we actually want to explicitly state what's in the bank. And that's why we wanted to define those variables really well. So D is dimes. So Dylan has 33 dimes. $57 quarters. Now, ironically enough, for this problem, when we go to part 3, Dylan's mom told him that she would replace each of his dimes with a quarter if he used all his coins. Determine if Dylan would be able to have enough money to buy a game priced at $20.98 if he has to pay 8% sales tax. Justify your answer. Now, what I really like about this part of the question is even if you didn't solve the system, this is an opportunity to tack on more points just by solving this equation. And that usually doesn't happen. Usually, with a 6-pointer, if you don't have these pieces in the beginning, you don't have a way to get this part. But here we do. So let's figure out how this works with what he needs to pay. So the game costs $20.98. but he has to pay 8% sales tax. So instead of multiplying that by 0.08, I want to actually put the 1 in front because that includes the $20.98 he has to spend. So now when we calculate this, we've got the entire price, including the sales tax, in one single calculation. So what we've calculated is that with the tax, he needs $22.66 to buy the game. So now, here's the really nice part. Dylan's mom told him she would replace each of his dimes with a quarter. So we don't have to worry about anything that happened before because we know he had 90 coins. So in this case, every one of those coins would be a quarter. So the amount of money Dylan has is actually 0.25 times 90. So when we do our calculation, 90 quarters is $22.50. So even though he would have had enough to pay for the game, he wouldn't have been able to cover the sales tax. So we do have to answer the question they ask. This is our justification. But if I don't explicitly state no, he will not have enough, I don't get full credit for that question. So it's a very small thing, but it's extremely valuable. Make sure you answer the question you ask. And this should be a full and complete 6 points for this question. So let's go over and take a look at the rubric. So here's the scoring guide that tells graders how to grade this question. So notice at the top is the 6 points. So to get the 6 points, it shows that we have both equations written. 57 is our answer for quarters with work shown and a statement saying Dylan will not have enough money. So see how it says Dylan won't have enough money is written. That's necessary for the 6 points. So here they show all the opportunities of losing a point, right? If somebody made a computational error, if they didn't justify their work, right? A method other than algebraic is used to determine the 57. So if you used NSolve to solve the system, you would lose a point, right? If you didn't answer the question about the coins and Dylan's mom, so as soon as we get to that part 3, if you only did the first 2 parts, that's 4 points. If you wrote your system of equations, got 57, and showed no work, you would still get 3 points because you get 2 points for the system. So the main reason I'm showing you this is just to demonstrate that even if you don't get full credit on one of these big problems, they really do try to set it up where you do get credit for every part that you